So when we add or subtract rational expressions, the one thing we have to have is a like denominator. So exact same thing on the denominators. So we're going to go ahead and do some examples where we start off and the denominators are already the same. Right? So we'll start with numbers just to remind ourselves. So let's say I have 7/6 plus 1/6. So my denominators are both 6. They're the same. So when we add, the denominator stays the same, so 666, and then we add the numerator, so 7 plus 1 is 8. So it's like you have 7/6 of one thing and you add another sixth, one more sixth of that thing, so altogether you have 8/6 of whatever it was you had. And then we should reduce that fraction, so it looks like 2 goes into both of those, so 2 times 4, 2 times 3, cancel the 2's, so 4/3 would be a perfect final answer. And subtracting this one, so I have 8/15, and then I subtract 2/15. So the denominators are both 15, so my answer starts with a 15 denominator. Subtract the numerator, so 8 minus 2 is 6. So 6/15 is the right difference. We've done the subtraction. So now we'll just see if we can reduce. So it looks like 3 is a factor that goes into both 6 and 15. So 3 times 2, 3 times 5. Cancel those common 3's. So 2/5. So rational expressions, it's the same idea. If our denominators are the same, we just add the numerators. And the new numerator goes over that common denominator. So 6 over x plus 3 plus 2 over x plus 3 is 8 over x plus 3. Now above, right, I said, oh, can we reduce? So here we would think about reducing, but since this denominator is linear, it's just an x plus 3, I would need a factor that had exactly x plus 3 in a set of parentheses on the numerator in order to be able to reduce. Obviously I don't, I've just got the number 8, so this is as good as it gets. Okay, here's another example. X over x squared minus x minus 6 plus 2 over x squared minus x minus 6. So same denominator, so my answer has that as its denominator, x squared minus x minus 6, and x plus 2 is the numerator. Now, this time my denominator is quadratic. It might be, right, because this is a math problem written by a math teacher, it might be that I do have a common factor and I should look to see if I can reduce. So the x plus 2, there's nothing to be done about that. It's just waiting to see if it's got a partner down below. So if I factor x squared minus x minus 6, what do I get? How does that factor? So we're looking for numbers that will multiply to 6, subtract to give the 1, or add to give the -1, however you think of that. I think of it as -3 and a +2. Hey, there it is, right? So the x plus 2 on the top, x plus 2 on the bottom. Now I can reduce those. Leave behind a 1 on the top. So just because I've canceled all of the numerator, remember, if you cancel all of the numerator, it still leaves behind a 1. It leaves behind a 1 if you cancel all of the denominator as well. It's just we can write fractions without a denominator, but it doesn't work if we write it without the numerator. Okay, so 1 over x plus 3. Okay, last one. Same denominator. That'll be the denominator of our answer. Go ahead and add those two numerators together. Nobody has like terms on the top, so they stay 3 separate terms. Again, question written by a math teacher, so probably not 100%, but probably at least half the time, right? There's going to be a common factor up top there, so you're going to want to look and see. So are there numbers that will multiply to 32, add to 12, look down here for a hint. Maybe there's an x plus 8. So if it's x plus 8, the other one would be x plus 4 to get the 32. I'm going to check the 4x, and the 8x gives you the 12x. It works. Now I have the x plus 8, one for the top, one for the bottom. Cancel them. So here's an example. I canceled out all of the denominator and left behind a 1, but I don't have to write it because it was in the denominator. So we'll just write that x plus 4. Okay, so now subtracting. It's kind of the same thing, right? We're just going to subtract the numerators. So denominators are the same. Always check that first. So x plus 10 is going to be our answer denominator. And then it's 2 minus 5. And 2 minus 5 is negative 3. X minus 8, I have the same denominator. So that'll be the denominator in my answer. Now we need to be careful on this one. Why do you think we need to be careful? So I have an x squared plus 13x for my first fractions numerator, right? So x squared plus 13x. I'm subtracting all of the second denominator or second numerator, and that second numerator has more than one term. So I need to subtract and then put it in parentheses so that I remember to distribute the negative sign. So x squared plus 13x, I'm just copying along, and then I have minus 13x minus 64 all over x minus 8. So the 13x and the negative 13x, those guys add away, and I just am left with x squared minus 64 for the top and x minus 8 for the bottom. So quadratic is up here on the top, so that means I should try to factor it. Difference of squares, so x plus 8, x minus 8. The bottom is still x minus 8. There's that common factor. So my final answer, I'll write it up here, is x plus 8. All right, last one. And again, we're going to subtract off both terms in that second numerator. So x plus 8 minus parenthesis 3x plus 2 all over 6. So write it again with the parentheses gone. So we're going to take the negative sign through. So minus 3x minus 2 all over 6. Go ahead and combine your like terms on that numerator. So I have a 10x minus 3x. So that's 7x. And 8 minus 2 is plus 6. And that's all over 6. Now, I can hear some of you saying, well, can I get rid of those 6's? And think about why you cannot. You cannot do that because this 6 that's in the numerator is not a factor. It is not 6 times everything else on the top. It's 6 plus, right, everything else on the top. So it's not a factor, so that means I can't cancel it. Okay, so big thing to remember when you're subtracting is to subtract all the terms from the second fraction. And a way you can remember to do that is just take that extra step. So take the step where you do the minus and then wrap that second numerator in parentheses and then distribute your negative sign and then simplify.